Now let's have a look at the model itself. Let's start with the grass growth agent. What you have here is a public property with a property description. This annotation tells our system that it's a value which is initialized from outside. So this grass regrowth per step, this property has to be public get set, that it is able for our system to initialize it from outside. And if we look in the config JSON, then you see that we have defined here this property and give it a value. So our system automatically, oh, where am I? There, initialized it. When we look at the sheep, here we have even more properties which are initialized by our system. Then we have here an init method. So we always want to have in this newest version of Mars, in all versions it was different, but in this newest version of Mars, you say an agent is a subtype of iAgent with a parameter type of the layer to that it is bound. Like when you remember, we said we add an agent and this agent lives on a layer. So that's exactly the layer we get here. And this layer can then be saved and used for stuff. And then you have always, so you have the init method and you always have the tick method. So in every tick, every agent has the possibility to act. And this agent is just doing something, changing the height of grass. So it is disputable of if this is really a good implementation of an agent, but in this case, it was used like that. So how does the layer look like? So our grassland layer is a raster layer, which means it can understand a raster file. So if we look at the config again, you see we just handed over a file, which is a grid CSV. And this layer does know how to read and understand the CSV file, and automatically everything else is done for you. You don't have to do anything more. You just have to say it's a raster layer and hand over a file, and that's it. And the same goes for different layer types. We have, for instance, also vector layers, and they just understand different types of inputs and use them and make them available within the model. So what you see is in the grass growth agent that now the grassland can be accessed with a position. A position is just a type which has an X and an Y. So it's a coordinate, and you can access the raster by coordinates, and you can set the values, or you can just access the values. Okay, so this all is within this grassland layer is a raster layer. What we have else here is we have two environments. These are special hash environments. And in one environment are the sheep, and in the other one are the wolf. That's just a design choice. You could also think about an environment which holds both. But then whenever you access it, you would have to distinguish, do I have a wolf now or a sheep? So in this case, it was separated. And we have an agent manager that is responsible for creating new agents, right? And this agent manager is automatically initializing the agent with everything which is required for that agent. So if an agent has requires to know different layers that are part of your model, you can just add them to your agent as public properties with a property description, and that's it. And it will automatically be initialized. Okay, So these environments are there, and the agent manager spawns here all 3 agent types. And it spawns as many as there are defined here in the count attribute. Okay. Let's have a look at the sheep. The sheep also has inputs: unregister handle, sheep gain fruit, and sheep reproduce. You see them by this property description. It also has an init method. And why did we separate? Why didn't we use a constructor and an init? Because we would like to have a method call, like this init call, which initializes additional information when we know everything which comes from outside is already there. So when you would have a constructor, then normally nothing is initialized. So you get all the parameters in the constructor, and that if you have a lot of input parameters, then you would have a rather large parameter list in your constructor. And now we say this init method is always called after everything from outside is already initialized. So you know everything which you might access, like in this moment here, when we calculate the energy of a sheep, we want to access this property, and you are sure it has already the correct value. Okay, and then we have other public properties which are not initialized from outside. But if they have a simple type, like string, int, double, and so on, and they are public, so accessible from outside, a public getter, then these properties are automatically printed to the output. So when you run your whole model, you will have an output file. In our case, we have a CSV. If you would have a database, then everything would be put saved in that or stored in the database. And this CSV file, I might want to open one. Might look like this. Let's put a wolf there, for instance. So you see there are some basic properties that are always stored, like tip and step and so on. And all others that are simple, that are public properties, like type and rule and energy, yeah, they are public properties with a public getter. They are also all stored in this output file. So if you want to add more, then you could add another public property. I don't know. Status, for instance. And now you could store anything in that and you would have it in your output. Okay. Okay. And then, of course, there's other stuff used in this model, but I think more or less everything is clear. So an agent has an init method where you finish the initialization, and you have a tick method where you perform everything that this agent want to do within this tick. Okay, any questions so far?
Could you repeat where I find the grids at the end, the outputs?
Yeah, so when you execute the model like this, then you see here within this structure, you have the bin folder where, depending on which kind of application you're using, everything is copied as bytecode, and here you also get the result CSVs. If you have not said you want to have a CSV as output, but you want a database, then of course it is stored directly in the database.
Okay, thank you.
Okay, then let's have a look. I run this analysis tool from R, and you see this is the way now the amount of these two agent types are displayed over time. And depending on my input configuration, that changes. Yeah, so it is up to you to play a little bit around with it and see if you might find a configuration where both lines stay stable, and that is called, what was the name for it? Lotka-Volterra equilibrium. Okay, last thing I wanted to show you. So now is also the time for questions. So if you have any questions, just ask right now. But if there are no questions coming, then I will also show you a visualization of it, which I just built this morning. Okay. So here you see a visualization tool, which was somehow implemented last time, and I just modified it a little bit for my thing. And if I run it now, then you see stepwise the simulation goes on. The green ones are sheep, the red ones are wolves, and you see how they move over the grid. And after a while, unfortunately, all my wolves die and some sheep remain. Okay, I let it run one more time, that you have an idea. Okay. I will stop recording now.